Welcome to the session Data Structure Sorting Gate Questions. At the end of this session, the students will be able to solve a data structure sorting problems. First gate question 2009. What is the number of swap required to sort an element using selection sort in the worst case? Now here the question is about the selection sort and the options are given theta n log n, theta n square and theta n into n log n. So the answer for this is selection sort, that is required theta n for the selection sort in the worst case. Now how it is, we will see. Now in the selection sort, find the smallest or largest. We can do in both cases. Either we can go through the smallest number or largest number, we will see. Find the smallest or largest element in the array, then exchange it with the element in the first position. If the smallest number we are finding, that we will be exchanging with the first position. If we are finding largest number, we will finding or we are exchanging with the last position. Then find the second small number and exchange it with the second number, or you find with second largest number, or you will be exchanging with the second last position and continue until the array is sorted. Now in this case I am using this one thing, that is the find the largest number element in the array, then exchange it with the element in the last position. So here we are working on the largest element. So in the array we are finding the largest element, which is the largest element, and then immediately we are going to the end of the array, we are putting that. Then we are finding second largest element, then we are putting at the second last position, third largest, third last position. Like this we are putting the values, exchanging the values, and we are doing this continuously till the array is getting sorted. Now here I am showing one example. Here we are having this array which contains 5, 1, 3, 4, 6, 2. Okay. Now first I will start with the comparison 5. So I will consider this is the value as a largest value. Okay. Then it will be compared with 1. So still we are having the 5 is largest. Then 5 is compared with 3, still 5 is largest. Then it will compare with 4, 5 is largest. Now it will compare with 6, now it is 6 is a largest one. So we are exchanging the value with the largest value with the 6. And now second step, whatever the largest value in the array we have checked is 6. Up till end we have checked that largest number is 6. Now 6 number has to be moved to the last position. So here it will be moved to the last position. If we are doing with the smallest number, then we will consider first one is smallest, then it will compare with 1. So 1 again we will be exchanged that 1 is small, then it will compare with everyone, and if 1 is small, then it will be exchanged to this first position. So here we are working on the largest element, so our largest element will be moved to the last position. Now we are going to find the second largest element. Second largest element will be, first we will be consider 5 is the second largest element, then it will compare with the 1, it is largest, we will compare with 3, it is largest, 4 largest, and with compare with 2, it is the largest. Now we will compare up to this, we will not go beyond this. So now 5 is the largest. Now 5 has to shift to the second last element. So here we will be shifting here second last element like this. Now it has placed. Now next third largest element we will be considered as 2. It will compare with 1, 3 and 4. Now 4 and 3 both are largest. 2 will compare with 3, that time it will be considered as largest. Then 3 will compare with 4, it will consider as largest. And this is the end. 4 will be now largest one, and it is having in the proper position, so no issue. Now next largest element we will be considered as 2. It will compare with 1, it is still largest. It will compare with 3. Now 3 is largest, so it will be placed at the same place, no issue. The next iteration 2 will be considered as the largest. It will compare with 1, it is still largest, so 2 is largest, so it will be shifted to this position. Now 1 is already done. So this is the way how we are finding the largest element and we are placing that to the proper place. So this is the selection sort. So here the idea we have done the same, just we have discussed. We are finding the largest element and keeping at the particular position. Now it is having disadvantage. It is running time is depend only slightly on the amount of order. Means how the order of array is, that accordingly our running position time will be required, because you can see here n is the length of that array. Then how much loop we are doing, that is j minus 1 to n minus 1. Sorry, 1 to n minus 1 we are running the loop. Then we will consider the first one as the largest, and then we will be in the loop, we will be comparing loop. Okay, so every time we will compare with the next one, next one, next one. If it is greater than whatever we are having, then we are exchanging the largest value with whichever we are finding the largest one. So then it will be the largest one. And finally when we are finding the most largest in that full array, then we are going to that position n minus j. Now here n minus j, at first time it will be here, so it will be the largest value. Then next it will run, that time j will be 2, then n minus 2, here it will be at this position, and second largest will be there, and we will be placing all them. So this is about the algorithm of the selection sort. So here one more question, answer this question by pausing your video. Which, it is a GATE 2006, which one of the following in place sorting needs the minimum number of swap? Just we have seen one sorting, so you can find out. So here is the answer, that selection sort. So selection sort performs swap only after finding the appropriate position of the current picked element. Means we are picking the element, it may be largest or smallest. So we are doing a big O notation n swap in the selection sort. Means how many numbers are there, that many swapping only we are doing. So in the insertion sort we have seen that we have to move, if that we have to make the room for that. So in this way here in the memory position directly we are swapping to that particular position. So the answer, correct answer is selection sort. These are references. Thank you.